Hello. So we're getting people joining now. So let's give it another minute or so and we'll get started right away with our guest, Massimo.
Hey, good evening or good morning, everyone. It's really exciting to be here.
Okay, so I think we've got quite a lot of people in, almost a full room. So I think we can get started. And so we are here for the office hours with Massimo Banzi, CTO of Arduino. And I'm really excited for this opportunity to talk to Massimo directly and get questions from the audience. And I'm really hoping in a lot of interesting questions. I've got a lot of questions myself, Massimo, so be ready.
I'm ready.
And before anything else, I want to give you the opportunity to introduce yourself and then we can take it from there.
Yeah, so my name is Massimo Banzi. I'm the co-founder of Arduino. And so during my day-to-day job is now I'm mostly working on the marketing side of Arduino, but I'm also a professor. I teach interaction design, and this kind of actually teaching interaction design is what actually generated Arduino. So I teach here in Lugano, Switzerland, and in other places where I run workshops. So that's kind of a short version.
I think that's good enough because I think everybody in here probably knows you. That's why they've shown up. So, so I'm really curious to start digging into some questions. So first of all, I'll just tell everyone that is joining that they can ask questions in the chat, and then we'll take them here, so we can ask them to Massimo. So if you have any questions, please share them in the chat, and we can get started. So first of all, I wanted to say I was really excited to see your talk just a few minutes ago. Actually, I think it was an hour ago. It was really exciting to see your talk on TinyML and how you are at Arduino making it really easy for developers to take machine learning and bring it to these like really tiny devices, right? And I wanted to ask you a bit more around how do you see TinyML progressing? You see a lot of users doing TinyML, and what kind of use cases do you see mostly?
Yeah, so there's some interesting things that I have been looking at. So there's an aspect that, for example, right now I'm helping out on a project that has to do with that uses the LoRa connectivity. So as you know, LoRa, you can only send like a message every 10 minutes, and it's got 50 bytes of payload. So clearly, you can't really send a lot of data. So the more processing you can do at the edge, at low power, the better it is. So you can, for example, analyze data in real time using one of these TinyML algorithms. So classic use cases, people doing predictive maintenance, so they pick up vibrations and sounds and they process them with different algorithms and they figure out if what they see, what they perceive, it's a correct or incorrect signal coming from the machine. That's one thing. The use case I was discussing in the presentation is if you were to build a very simple low power camera that counts how many people are in a room, estimates how many people are wearing a mask. That's another use case. The interesting thing is that if you do that on the edge, the only information that you send on the cloud is there are 20 people, which is very important also for every aspect related to privacy. So if you process everything on the edge, you can, in a way, you can maintain privacy. So there are no images, no sounds that leave the device. If you do it with what they call TinyML, it means you're doing it on a device which consumes a lot less power than a really big, machine. I mean, even a Raspberry Pi uses quite a bit of energy when it's running some of these algorithms. So if you want something that can run on a battery, you have to do these kind of TinyML. So, for example, today we announced this vision module for the Portento. For example, for that one, we picked a low power camera, so you can run the whole thing very low power. So I think there are aspects related to privacy, aspects related to doing the computing as close as possible to the thing, where the things are happening, and also low power. And there's also another interesting aspect that we can touch later on. Sometimes, since the hardware you're running things on is quite simple, it is also a good platform where to learn about machine learning, because you start from simple things. And so it's an interesting thing. It sounds counterintuitive in a way, but it's actually a very good way to get started, because you have to start with simpler, older algorithms sometimes. And so you get to learn a lot about the basics before you move on to larger machines.
I like that. I like the idea of starting with something simple that you can grasp right away and then evolve into something more complex. And to that point, actually, I was so I looked at your, I was watching your presentation, and you were talking about the Portento H7, and you've just released today a new vision shield that you can apply to the Portento H7. So now you have this potentially, this platform that can allow you to do vision applications, machine learning applications on these, again, microcontrollers. But there is a but, because we talked about simple or kind of simpler Arduinos, but now Portento is actually a pro Arduino, right? So what is the difference really, and what does it unlock?
Yeah, so the interesting thing is that for the last few years, we saw quite a lot of people using all sorts of Arduino boards, even in professional applications. So there are industrial equipment that if you open it, there is an Arduino Mega inside. The Arduino Mega was never imagined as something that runs a piece of equipment, and yet it does. No, there was even a picture of people using it at CERN, deep in the belly of the particle accelerator, because they thought, well, if it blows up, it blows up. And then they were shocked to see that it resisted all this radiation and continued to operate. No? So in a way, people have been using it for quite a while. But now that people are actually building serious things with Arduinos, we created this Portento platform, because it is obviously a very powerful microcontroller. It's an STM32H7, which has two microcontrollers. It's a ARM Cortex-M7 and ARM Cortex-M4. One of them is running at 480 megahertz, plus the Cortex-M4 is running at 240 megahertz. Also, it has things like, it's got a lot of external flash, RAM, it's got USB-C, it even has video that you can route through the USB-C. It's got Wi-Fi, Bluetooth. So it's designed to be both super powerful, but also very low power. So compared to probably a Linux machine, you can control the power consumption a lot. And we also created some tools where you can program it to the classic Arduino language, but underneath sort of the surface there is Mbed OS. So you're running on top of a real-time operating system. And you can finally access the operating system from Arduino, so you can do real multitasking. You can implement all the different things that an operating system gives you. They're available to you in Arduino. And we also developed a library that allows two core to communicate. So you have this RPC library, so that you can make calls from one core to the other one and back. So you can enable some very interesting scenarios where you could be running an application on the Cortex-M4, which is supposed to be low power, and then you turn on and off the Cortex-M7, depending on the fact that you might need to run some kind of an algorithm, then you turn it off. Or you can even program with different languages. So for example, the Portento supports also Python, for example, so you could be running Mbed OS with C++ on one core and Python on the other. So, and also the hardware itself is developed at industrial temperature. So it is designed to withstand a wider range of temperature, vibration, and all sorts of kind of, so in a way, stress when it operates. So in a way, it's now something that you can put into a product. Also, there's like an infinite amount of, infinite no, but it's got 160 I/O pins that you can use in different ways. So, it's something that just covers quite a lot of use cases, still being reasonably low power for being such a powerful little machine.
And you were telling me earlier that actually, before I ask this question, let me just say to everyone in the chat that you can ask questions. This is actually live. It looks like Massimo is so great at speaking that it looks like it's been recorded, but it's live. So if you've got any questions,
this is the time. It's 8 p.m. over here.
So if you've got any questions, please ask them in the chat. And so I've got another question about this. So you talked about low power, right? Like obviously microcontrollers are low power. Our microcontrollers are low power. But what's interesting about this this board is that actually you've got a dual core, right? And you were telling me before when we chatted offline that actually there's a lot of interesting use cases, because what you could do is turn off one of the CPUs, right, and just leave the other one on, right?
Yeah, so you have the freedom to really play with the two cores, and also, for example, the board has a battery charger on board. It's got a connector for a LiPo battery. So it is designed from the ground up to be something that you can in a way so it's designed from the ground up to be powerful, but also be kind of power efficient. So you can turn on and off peripherals and cores depending on the type of application that you want to implement.
And that's really interesting, right? That's the power of embedded, and this is, you know, now in an Arduino, right? Like you can device your system as you know, as you need for your power budget, cost budget, and it's quite interesting that now, you know, Arduino has this capability with this dual core capability, and you can turn one off and keep the other one on, and so on.
So one of the things that I wanted to add is clearly one of the things that the reason why we took us a long time to build this is that also we tend to spend quite a lot of time on the user experience itself. Normally dealing with this kind of hardware would be quite complicated using classic development environment, while in Arduino you get the user experience. You plug the cable, you write your Arduino code, a piece of code that was running on an 8-bit Arduino, you cut and paste it, you might need to make a couple of changes, you press the button, and suddenly it's C++ running on top of Mbed OS that's running TensorFlow. So that kind of one-click experience is something that I think one of the values of Arduino that we try to keep pushing.
It's really interesting. And so we've got one question from Aniti here. What is your favorite TinyML project you have made so far, Massimo?
Well, so I have, so in this kind of path to work, to understand more about what it means to do TinyML, I've started to do classes with my students now since 3 years ago. And so we work a lot, for example, on the user experience and how you could use, for example, TinyML in user interfaces, because that's another interesting world. So we did a lot of funny applications. So I will tell you about a couple of funny applications, and then we'll, just to remind ourselves that not everything is, predictive maintenance or something like that. So for example, one team developed this fantastic device that allows you to record when your neighbors are being too noisy. And then whenever they make the same kind of noises, it just hammers the wall with a big hammer, just to, I know this is a stupid thing, but it's just to show you that once you start to think about creatively about these kind of applications, then yes, TinyML, you can use it to recognize sounds. For example, I used the Edge Impulse tools to do sound recognition on our Nano 33 BLE sensor, which has a microphone on it. So you could recognize, for example, somebody designed an application where you could detect coughing and sneezing, which could be, in the kind of world where we live, it's probably interesting. I did an application for something that we will release as a gift to some of our partners. It's the board that detects when your coffee is ready If you have the coffee pot on the classic Italian Bialetti coffee pot on the fire, when it's brewing, it will send a message via Bluetooth that says the coffee is ready. So obviously these are like silly examples, but they are also very interesting to me, especially when I work with my students, to understand, to put myself in the same situation when we made Arduino. So to work with people that are very creative, they don't really understand the nitty-gritty parts of the technology, but they have a lot of ideas, and once you give them a technology, they run away with it, and they really start to look at different aspects. So, you know, one of the things that I said in the past a few times is that sometimes when people used Arduino, they were doing embedded development, but because we didn't tell them that they were doing embedded development, they didn't feel the pressure and they built some amazing stuff. What I want to do is for people to be able to do machine learning without knowing that they're doing machine learning, so they don't get nervous and they can be creative. And that's—
I love that.
Yeah, it's important that, because when you start to give names to things, people start to get the pressure, you know, they're like, oh shit, this is too complicated. While if you just say, oh, we're just building some fun stuff, then out of the fun stuff, sometimes, you know, some interesting projects come out. And because you don't put the pressure of like the seriousness of what, you know, people call some of the things they do.
I'll pause you a second here. That was a really interesting thought. Hold it for a second, because we'll go back to that. But we're letting more people in from the waiting room, so we'll have a bunch more people joining us. So we'll continue in a second.
Yeah.
Hi everyone. Thank you for joining. We've just had the first session, but we have now more people joining. So thank you all. This again is the open hours with Massimo Banzi, co-founder of Arduino. And we were talking about some really interesting TinyML applications, and we'll just continue from there. Massimo, by the way, before saying that, I was just going to say you'll be able to rewatch this. So if you've missed the first part, you could rewatch it. It's going to be online afterwards, so feel free to go and watch it. And the other thing is, if you've got any questions, please could you ask them in the chat so that we can bring them up? Because as we said before, this is actually live, so we'll be able to answer any questions. So yeah, Massimo. So let's. I think you just brought up a really interesting point about people not knowing, or the kind of idea of let's get people to build fun things without telling them it's hard, right? Like I think sometimes when I was in university, I remember you start this course and someone tells you like, oh, this is going to be a really hard course. Your friend that has maybe done the course before tells you like, this is going to be super hard. And you start with this kind of bias, right? And then everything is much harder. Where if you start and think, oh no, this is something I love doing and it's fun and it's easy, it's much easier actually to then get stuff done, right? So that's a really interesting thought.
Sometimes it's all about the way you call things, no? If you call it with something that people associate with complexity and, sometimes it's also general thing that I've experienced, for example, while teaching, is that people think that the technology is really, really hard, that it is impossible for them to really go into the technology, And then, I remember when I was, 7-year-old, I started to learn about electronics using this toy that this German company Braun used to make, which was partially designed by Dieter Rams, so the famous designer who inspires most of the product that Apple has been designing for the last 20 years. And it was just a toy for kids, and I was doing electronics, but there were like funny characters walking around and you would just snap together cubes. I was just building stuff. So I didn't realize I was learning about electron resistors and capacitors and, flip-flops and digital circuits. I was just a 7-year-old kid that was building stuff. So it is also interesting that in the world of technology, if you're trying to make something very simple to understand, you're doing it for children, it's fine. Everybody's happy. While if you do something for adults, you're trying to simplify the life for adults, and like, oh no, come on. You're making people stupid, they're not learning correctly, But each one of us is different, and we all have different learning styles. And whenever the school system is trying to teach the same way to everyone in a class, you're clearly gonna have problems, because each one of us learns in a different way.
Yeah, no, I completely agree. And you know, please don't change what you're doing with Arduino, because I love it. So, so I think this, you know, it's great that we can open up to more users, right? And you never know what's going to come out, right? Like sometimes, you know, someone might start in high school or maybe even before that, right, with Arduino, and then later on they might develop the next big something, right? And I think that's the power of technology, is putting it in the hands of many means that you get more innovation, right? So I think this is it's exciting. We've got a couple of questions from the audience, so let me read. So David is asking, iShotJR is asking, he didn't realize that there were shields for the Portenta, and he's asking, how does that work mechanically? What is the standard?
So there are two ways you can do that. So the Portenta has the same through-hole connectors that you find on the Arduino MKR series. So you can bring out about 28 different pins, and for a lot of things it's useful and it's enough. And you can use it with some of the shields that we already have. So for example, we have an RS485 shield, which is, you know, not a prototyping tool. It's a more, you know, more production ready, because it's galvanic separation and all of that. We have a CAN shield, we have GPS, we have a bunch of other shields from the MKR that you can reuse. Or if you have a product which is designed for the Portenta at the back has two high density connectors that bring out 160 pins. So on that thing, for example, you have several different communication ports, a lot of GPIOs, you get Ethernet, you get CAN, you get a lot of the different buses broken out. And, you know, that is going to become a standard. So we're going to publish, we actually already published some of the documentation on how these pins work. So this is interesting for the kind of things that I sometimes jokingly call the backpack, because essentially it's a board you can snap at the back of the Portenta, so it becomes a little sandwich. And that one, for example, this Vision Shield that we just released has a low power, high max camera, two MEMS microphones, and then it comes with an Ethernet connection and an optional LoRa radio module. So you can choose what kind of connectivity you want. So this standard, you will find more and more products that support this standard. Actually, one member of the community designed a PCB where you can snap the Portenta on and brings out basically all of the 160 pins, so that you can.
Oh, that's cool.
Yeah, so it was
really
completely designed by the community, which it's nice when this happens.
That's really nice. So it's a breakout board for the Portenta.
Yeah.
And is it available to buy, or is it?
So this person designed it. They put the files online. So if you want,
okay, it's all open source.
And so now we're figuring out, can we make it, for example, in collaboration with this person? So some discussion is open. There are also some other modules that are coming out for the Portenta in the near future. So
awesome. The next question is from Wachira. They're asking, would Arduino consider collaboration with another hardware maker? And then he says, more specifically, Raspberry Pi.
Well, so we always collaborated with hardware makers. For example, a lot of the products that we did in the past were made with Atmel and then Microchip, and then we work with STM, but also we work with Adafruit a lot. We have some products that are designed and manufactured by SparkFun, but they are listed as official Arduino products. So we have done a ton of these things and we continue doing them. Just to correct something that's in the chat. So the Vision Shield was developed by us. So it's our design. But then we talked to OpenMd, because we wanted to be able to run their software on our hardware. So the collaboration with OpenMD is more on the software side, and the hardware is all internal. But we did select a camera for a very specific reason. So the camera we are using is a HiMax camera, which is a camera that was recommended by the TensorFlow team because they were using that in another sort of TinyML vision examples. So it's in a way, you know, we picked that one because it's very good performance, but it's very low power, and it's something that you know, the TensorFlow team already used. So sometimes the collaboration happens like this. So I love Raspberry Pi. I've been to visit them a couple of times, and you know, so I know. So we would love to do things with them, and we have discussed it in the past. So you'll never know.
Cool. So there is another question here that's interesting. Actually, yeah, whatever happened with, so I think, you know, we probably need to, so I know a bit of this, so maybe, I don't know how much you know, but there is talking about drones. So whatever happened with ArduPilot and drone code seems like they disappeared or dissolved around 2016. Are there good drone kits to build on and use on Arduino? I'll say, before leaving it to you, I'd say that I don't think they're dissolved, actually. I think our drone code is a very vibrant community. They just had their developer event this summer. It's a PX4, that's the open source flight stack. So it's live, and actually there's a lot of developers. I'm less familiar with ArduPilot. I'm not part of the community, but you know, they're still alive as well. So Massimo, do you have any insights on the
So I don't know very much about this. The one thing that was very interesting, probably like maybe a couple of years ago, I found it was very, very cool that a drone for like $50 appeared at Walmart, and it was powered by ArduPilot. And if you think the path from ArduPilot, from where it started off many years ago, and then becoming the software behind a consumer product that arrives at Walmart, it is a big story behind, you know, open source, no? So I think ArduPilot is alive, and I don't know about Arduino-based drone kits. I think that now the Portento would be really, really good for a project like that, because with just a motor driver kind of PCB, then you have the right computing power and all the different ability to run something on the processor itself. Because at some point I've seen people doing ArduPilot, they start to break out the computing on different processors because the original 8-bit was clearly not capable. Then they moved to STM32. Now with this, you can do a lot of crazy, interesting things. So I think now this is the time to do a drone. There was a question about no code, low code in the hardware space.
So yeah, I did miss that actually. Yeah, you're right. What do you make of no low code paradigms in the hardware space? For example, Scratch. Is it viable more so in production and then the education space? So I guess he's asking, is it viable in the production space as well as in the education space? Things like Scratch and other things like that.
We have to separate the no-code, the low-code kind of paradigm from the visual paradigm. So Scratch is a tool for teaching programming to kids in a visual fashion. That one is clearly an educational tool. It's designed to run in a browser. It's probably a different tool. The no-code, low-code aspect of things, it's actually something that we experimented with. For example, with the Arduino IoT Cloud, because personally, I think that there are now different levels of what you would call an embedded developer. So clearly there are embedded developers that work really close to the metal, and they are the ones that developing, for example, EmbedOS, or they're developing the low-level drivers. They deal with the silicon and all of that. And then you have people who develop applications who more and more, they are basically composing bits of code that exist and they assemble them and they just write some of the glue, no? But in some IoT application, for example, the Arduino IoT Cloud, you go into a window and you define what properties your object has. You define how frequently or how the data gets exchanged. And then you press a button and the cloud generates all the code. And then you just have to add the code to read your sensors. And then you're basically done. I mean, if you want to build a simple IoT device that takes data and brings it to the cloud and responds to command and turns things on and off, most of the code is designed for you. And so I believe we're going to see more and more scenarios where embedded developers are basically composing libraries, composing macro blocks of functionality, and they're just building some business logic, and in some situations, this business logic is designed through some kind of an online tool, for example, where you basically specify what your device is supposed to be doing, and it just generates the code for you. And that's, I think, some kind of scenarios that we will see a lot in the future.
Yeah, and I think just to add to that, I think once I remember you describing Arduino as an onion. So you said that you could kind of unwrap it and go inside. So I think what the power here is that you make it really easy for someone to deploy, or to actually build an application, but then you also allow them to go in and change stuff, because as you said before, it's all built on Mbed OS, real-time operating system, professional real-time operating system. So if anyone wants to go in the depth of the hardware and software, they could do that, right? They could optimize their software to run more effectively on their platform. So it's really interesting because you're kind of combining the two things, right? The abstraction layer with the low level potentially interfaces that you could get to. So it's I think it's super powerful. So yeah, it's exciting to see all this new developments. I think I was reading in your blog that you just wrote on the ARM blueprint that you were talking about how a lot of the students or a lot of the people that that have started, like using Arduino 15 years ago and so on, right? Like are now probably in university or actually working, right? So they've started off and maybe the first experience on an embedded device was Arduino. Yeah,
it happened to me once. I was in Munich. I met a product manager for a specific piece of silicon at Bosch. And this guy said, oh, I learned about hardware in school with Arduino, and then I graduated, and then I'm here, and Arduino created essentially my career. No? So his first approach to hardware was when he was a teenager, let's say, with Arduino, and then kind of directed his. It was quite. It was clearly very, very nice to see this progression. No, so
yeah. So let's go through another couple of questions. So there is one, is Arduino ARM working with any head-mounted computing, Vuzix, Facebook, RealWear? I imagine, I don't know if the question is related to the software or the hardware, but anyways, from an ARM side, I'll just say that, we provide designs for CPUs and other IPs that anybody can use in their designs. So, there are probably head-mounted computing platforms out there that are ARM-based, right? So we are working with other companies in that sense. And then I don't know, Massimo, if you got anything to add on the Arduino side.
No, at the moment we're not doing anything in that space.
Cool. And then a really interesting question from Fabrizio here. So he's asking, what would be the main challenges for a developer to migrate from a friendly Arduino-based environment and very capable hardware like Portenta to a dedicated product design?
Well, actually, it's interesting because if you were to ask me this question probably 3 years ago, it would have been a more difficult question. Now, actually, I think there is a path. As in, you can start with Arduino and program your Arduino in the classic way. So you use the Arduino IDE and all the different tools. Right now, I would say even the Arduino code, if you're building a lot of applications, it's enough. Then you start to look at, now when it gets interesting is when you start to look at the platform that we are developing now, which are based on Mbed OS. So suddenly you have an operating system. So a lot of the things that were more complicated to do with the classic Arduino environment, you have access to multitasking, semaphores, all sorts of different constructs that operating systems give you. And then now you have tools that allow you to do real debugging. And around debugging, there's quite a lot of things that are coming out in the pipeline very soon. But you can start to like serious debugging at the lower level. So if you look at, for example, the NanoBLE Sense is a Cortex M4 from Nordic, the Portento it's STM32. Then you can even use tools like Mbed Studio. So you can migrate your Arduino code into Mbed Studio and you can take your code to another level. At the end of the day, the Arduino code itself is LGPL. The Mbed Studio is Apache. So basically, sorry, the Mbed OS is Apache. So basically, you're only required to open source, quote unquote, any changes or improvement you do to the Arduino library itself. But your code stays with you. So if you're developing an application, your code is yours. Nobody can take it away from you. If you're starting from the Arduino hardware and you want to make your own hardware, you have two directions. You can start from scratch and redesign everything, which is clearly, it's possible, it's doable, it's a bit more risky, especially with something like Portento. It is quite complicated to get a board like this working. So I have two options. You just design a board and you snap a Portento on it and you're done, like a number of people are now doing. Or you can now license the design of an Arduino board for commercial use. So if you want to build something which is a modified Portento, it's going to be cheaper and faster to just come to Arduino and say, I want to license the use of the Portento to make it into something else. And you can actually now do that. So effectively, you can migrate from a prototype that you build on a breadboard to something that's working, mission critical, developed and debugged with professional tools seamlessly with the tools that we have and the tools that we collaborated with ARM.
Thank you for that. I really liked the question because I thought, I was thinking the same answer as you, right? It's like, now it's easy. It should be very, very easy. So actually, if anybody tries and wants to give any feedback to Massimo or me, I'd be interested to know the journey and, what you're developing.
Also, you can write to us, sorry, one thing that, you can also write to us directly sometimes and ask for help. And we have helped a bunch of people. Sometimes people don't even think about it, but we've had people that emailed us, I'm having a hard time doing this. And if you're building a commercial application, we're happy to help you because we want you to succeed. We want you to say, hey, I developed this thing with Arduino and it works and it's in production.
Yep. And I'll reiterate that. Actually, I'll say, reach out to me and to ARM as well, because we're also happy to help. So if there's anything that we can help with, we'll jump in. So the next question, actually, before I go to the next question, I was going to say, I think we've had some more people join in. So if you've got any questions, write them in the chat. We still have 20 minutes to go. So if you've got any other questions, feel free to write them in the chat and we'll read them out. Okay, so again, David is asking an interesting question. So he was saying, he said he experienced, he didn't like Python on hardware before. He thought it wasn't really fit for purpose, but then he tried Python and he actually fell in love with it. And he's saying, is Arduino doing or planning anything with MicroPython?
Well, the answer is yes. So for example, this OpenMd collaboration that we are doing, OpenMd, it's basically MicroPython in a way specialized for computer vision with all the different algorithms in there. You can even do TensorFlow with it. But it's essentially a version of MicroPython. And, I meet a bunch of people that come from all sorts of different places and different experiences. So, for example, I've had people say to me, well, we mostly do web development. We would love to do devices as well because we do web development for IoT, but our team is Python. So, they want to use Python on the hardware. I've had other people who said, we use Go, we want to use Go on the hardware. So, for example, we have a collaboration with people who do TinyGo. So they release TinyGo that runs on some of the Arduino-based, ARM-based products. So you can do Go. So, in a way, for example, the Portento, it's an interesting situation where you could be running Python on one of the cores and use the other one for if you have some very, very, very precise timing and low power requirements, you can first run that code on the Cortex-M4 and then have the kind of Python kind of control what's going on in the Cortex-M4. So you can partition your application like that, and you can take advantage of the two cores. So I think it's now something that's becoming, viable for some types of embedded development,
Yeah, and it goes back, I think, to our previous conversation as well around, sometimes like the abstraction that you do takes away some optimizations, but actually simplifies the development, right? So it's a trade-off. I think, I like to always think back on when object-oriented programming got introduced, right? And people were saying, oh, but this is creating a lot of overhead and, introducing a lot of overhead and the code will run slower. And then the CPUs got faster and faster. Now, like nobody would go back to straight assembly or C, right? Like everybody's typing, it's doing stuff in object-oriented and, all sorts of different languages. But so it's, the abstraction layer increases, but actually, you take the cost, but it makes sense it becomes easier, right?
For example, from my point of view, I'm happy to use Arduino sitting on top of EmbeddOS, because if I'm running on an ARM processor, do you think it's better if I write the lower layers of the code, or if I'm sitting on top of a library that's written by an ARM engineer who knows what he or she is doing? I much rather be sitting on the, standing on the shoulder of a giant in the way that, I have ARM engineers who write the code and I'm, sitting on top of their code, as opposed to me trying to do the lower layers and then, I don't know what I'm doing. I don't know the architecture well enough. That's why this layering that's happening right now, people should position themselves at the right position or in the stack. I develop applications. I rather sit on nice, powerful, debugged, serious code made by other people and develop applications.
Yeah, and I think, this goes back to the concept that you're opening up to a lot of, you call them experts, but they're not embedded experts, right? Experts are doing other things, expert in other fields.
I think this is an interesting situation where we are right now. When you talk about professional developers, in our world, we immediately think about embedded developers. But effectively, what's happening is that there's another category of people who are expert in their own field. So maybe they build some kind of machinery. So they are not specifically an expert in understanding all the intricacies of what happens inside a Cortex and something processor, but they are an expert in their own field. So they want to build devices. They don't want to become an expert in all the intricacies of what's going on in certain parts of the processor. They want to build an application. And that's what happens, for example, when people develop on Linux. Sometimes they don't even know what's going on in most of the layers of their machine. They just write code, and because they build applications, and it's now happening. The same is happening in the embedded development.
I completely agree. We could go on about this for hours because I'm really excited. This is really what excites me, right? The fact that we're changing, the world of embedded is changing today, right? And it's exciting to be part of it. But let's take more questions from the audience. So Francis is saying, what path would you recommend for teaching STEM and coding? He's mentioning a few things here: Scratch first, then JavaScript, and then others. What is the best language progression for education, K-12, and even into college?
Wow, that's a big question, because effectively, again, you know, people have a lot of different theories on how this should be taught. And clearly I have my theory, I have my experience. So I can say for children, I really like Scratch as a way to get people started, because it is visual in a way, but it is still teaching you about the fact that, you know, it's a sequential lines of code. No, sorry. Then in a way you can some people use, you know, there's really a lot of people, they use Arduino to introduce programming to kids. Maybe when they are in junior high school, you can start using Arduino. Some other people prefer the path of going, for example, to Scratch to Python and then MicroPython. That's another path. JavaScript is more a direction that Microsoft wants you to take, because they want you to learn, you know, they have make code, and then they kind of take you to TypeScript, which is kind of their favorite language. So for example, in the Arduino world, one of the things you can do, you can still use Scratch to teach the basics and all of that. There are very interesting modules that exist to connect Scratch to Arduino. So you can then start teaching kids about the hardware without programming the hardware, using Scratch to control the hardware. And then, for example, there are things like P5.js, which is essentially a JavaScript version of processing, which is used a lot to teach the basics of programming. But the philosophy is the same of Arduino, because we all kind of descend from processing. And so once you learn through P5.js, which only requires a browser, you can then move to Arduino very easily, and there's a lot of shared knowledge there. One of the advantages of Arduino is that there is a lot of teaching material, like a lot. So a lot of teachers like that.
Awesome. Cool. So another really interesting question from Wachira. Should no low code be an open framework with a defined specification like REST or GraphQL, or bespoke solutions implemented like Node-RED or Johnny 5? Do you have any views on that?
No, the way I'm looking at low code, no code right now is mostly, imagine that you're trying to build some kind of an application. So for example, in the case of Arduino, you could say, I'm trying to build an IoT application. And there are components that go on the cloud, and there are components that go in the device. Since a lot of the issues that surround the life cycle of an IoT device are pretty much understood, reasonably well understood, then you have building blocks that you can just use to solve some of these issues. So, you know, for example, if you use a platform like Pelion, you know, you have device management that comes out of the box. So the Pelion client will take care of a bunch of things inside your device. No? So one of the things I can see these platforms where you have some kind of a visual interface, which is not necessarily something like Scratch, it's something like much, sorry for the stretch, but imagine something like if this then that. No, but a much better version of if this and that. So you define what you need from the device with some kind of a visual sort of UI, and then the system generates the code using well-known components that are debugged and quote unquote certified if you want. And then you assemble it, you compile it, you put it in the device, and it runs, and you concentrate on the high level issues surrounding your device, and you delegate some of the complexity to this. There's still a lot of development that people do that where they almost start from scratch on everything, which is a huge investment. I understand the programmers love this idea that they have full control on what's going on, but sometimes it is a huge investment. So this is what I see now. But yeah, if you want to do like a REST call, it shouldn't be like a low-level thing. There should be like a block that says, do this call, deal with all the problems and issues, and the connection dies, I time out, oh my God, I'm sleeping, what happens when deal with all of that and just give me the data. So this is the kind of stuff that I see and I want to see.
Awesome. Well, thank you for that. One question from Carlo. What about Rust? Any plans to support Rust on Arduino in the future?
So some people are using Rust on microcontrollers. Inside the Arduino development team, there are some hardcore Rust enthusiasts. So they keep pushing for some kind of official support for Rust. It is kind of complicated because in a way, you want to be as agnostic as possible, but then there are really tons of different languages. Now, I was reading like a few weeks ago about somebody has a Lisp-based embedded development framework because they think Lisp is perfect for embedded development. So clearly, there's a lot of different languages, and we are not equipped to support them all properly. So, but I can tell you that Rust is something that the team is looking at very, very closely. There was also a question about the Portenta as 8 megabytes of RAM.
Yeah, so yeah, they're asking, so David Aishajar is saying he's excited about the Portenta having 8 megabytes of RAM or 16 megabyte, and 16 megabyte of flash. And he's asking, can you use MIPI or USB cameras with the same tools or only with the full shield?
It is possible to interface a MIPI camera to the Portenta because the processor has the capability. And so you would have to build your own interface, but once you build your own interface, you can. I think it's technically possible to use a USB camera as well if you plug it through the USB-C with an adapter. I don't think right now Arduino has the software library to implement all the stuff that comes with it, because USB host, yes, we do that. The problem is then once you are implementing the UVC protocol in order to understand what the camera is sending you, that we don't have yet. We don't have. So right now, it's just simpler just to get the shield and plug it in.
Cool. Sounds good. So I think we're about to close. We've got 4 minutes left. So is there anything, I guess, because we don't have any other questions, I don't think we missed anything. Is there anything you want to touch on before we close? Any other recommendations or thoughts that you wanted to share with everybody?
Yeah, one of the interesting thing is that one of the things that we are doing right now, which seems quite a bit of a task, is that a lot of people are still thinking about Arduino as the classic 8-bit board. That's kind of what they have in mind, and they don't realize that we've been making ARM-based boards since 2011. So it's now approaching the 10th year. And it's kind of strange because, sitting on the desk in the corner of this room, I have an Apple II, which Apple released in 1976. And it would be like people look at Apple, and instead of thinking about the latest MacBook, they still think about the Apple II, and which was an amazing machine, but it's an 8-bit processor with 64, well, that one has 48 kilobytes of RAM. So the question is, try to understand that, the 8-bit was a starting point for Arduino, but the mission has always been the one to make complicated technology simple to understand. So a few years ago was, we moved to 32-bit ARM, and then we started to do IoT, and then we explored every single protocol, and now we do more powerful microcontrollers. We've even built products that were a Linux machine and an Arduino together. We now have this powerful industrial range. And it also comes from the realization that there are people out there who are using Arduino to build applications. We have people we work with that build entire machines that automate things. You know, I met people who built with an Arduino machine that assemble and test coffee machines, or assemble and test parts of cars. So it is the kind of more professional industrial use of Arduino. It is a fact right now. And so in a way, you know, have a look at what we are doing. And there's a lot of interesting stuff. And we also have hundreds of open source repositories that you can go to GitHub and go through. We are releasing a ton of code every day. And a lot of the code that we are releasing could just be what you're looking for. But just kind of go beyond the surface, go beyond the history. You know, the 8-bit Arduino was started off a long time ago. It's kind of like the Apple II of Arduino, but we've had other machine released in the meantime. So just, you know, have a look at what we are doing now.
It's exciting. I see, you know, I think every time we speak, I see, or we talk about new things coming out, and it's always so exciting. There's so much coming out in the Arduino world. So yeah, it's really exciting times. Massimo, I think with this we can close. Thank you so much for joining us and for, you know, giving a chance to all these people to ask you questions and being so open with your answers. So really appreciate your help and your effort in chatting to us today. And if you've not seen the talk from Massimo yet, you can go back and watch it. He's given a talk a couple hours ago, so you should be able to get a hold of it now. It should be, you know, online.
Yeah, it's already available.
Exactly. Yes. Perfect. So yeah, if anybody wants to watch that, go ahead. And thank you again, Massimo. Thank you everyone for joining in as well and asking questions. Thank you for being so lively and excited about everything. Cool.
Thank you very much.
Thank you.
Bye-bye.
Thank you, everyone.